Pay attention. ksqlDB isn't a good fit for BI reports, ad hoc querying, or queries with random access patterns, because it's a continuous query system on data streams. In this lecture, we will learn ksqlDB architecture and the inside components. A typical stream pipeline consists of the source databases and the apps, creating events that feed into Kafka topic Y connector. A streaming processing will transforming, filtering, and aggregating the events. And the result will be called the results data. The results data will be brought back to the Kafka topic, target topic. And then another sync connector will transfer those results data to the system databases for application use in future. This is the standard system designing. But we can find we should to maintain different components and services. Image our system and need more than 10 connectors for data ingestion and sync. More than 10 streaming instances for data transformation. Deploying, scaling, security, monitoring individual system will be a huge work and difficult. Architecture with the ksqlDB is much simple, as many of those external parts have been consolidated into the tool itself. The ksqlDB has the primitives for connectors and is performed stream processing. It also features materialized views, so that your data can be queried just like a database table directly in ksqlDB, without needing to be sent an external source. As you can see this figure showing, the ksqlDB can define the stream processing queries statement, and we also can define and maintain the connectors used for ingestion or the sync. And the result can be management by the materialized view. So we no need to deploy the individually streaming application instance of the individual connectors for source and sync. As you can find, the application will be consumes and queries the data from the materialized view directly. No need to consume the data from the target topic from the Kafka, right? ksqlDB server comprises the ksqlDB engine and the REST API. ksqlDB server instance communicated with the Kafka cluster, and you can add more of the instance as necessary without restarting your application. And it is not difficult to find. The ksqlDB server is the stateless. It's just the computation engine, because the ksqlDB server will not restore any data at all. The data will be stored at the Kafka cluster. ksqlDB has those main components like this figure showing. The ksqlDB engine. The ksqlDB engine executes SQL statement and queries. You define your application logic by writing SQL statements, and the engine will build and run the application on available ksql servers. REST interface. The REST server interface enables communicating with the ksql engine from the client, the Confluent Control Center, or from any other REST client. ksqlDB CLI. The ksqlDB CLI provided a console with a command line interface for the ksqlDB engine. Using the ksqlDB CLI to interact with the ksqlDB server instance and develop your streaming application. Also, if you use the Confluent product, such as the Confluent platform or Confluent Cloud, you can use the Confluent Control Center, interact with the ksqlDB directly.